What would you do if you knew how to save the planet from climate change? We're now going to talk about Plan B, which involves reflecting sunlight back into outer space. This is a new field and therefore requires research. The question for scientists is, how can we reflect approximately 1% of sunlight back into outer space at a reasonable cost without causing harm? We are already reflecting sunlight since it reflects off man-made air pollution. More specifically, it reflects off of sulfur. It's possible this is a key element in solving the climate problem. Let's explore this further. Sulfur is an element on the periodic table and it is present in large amounts within coal and oil. Therefore, it is typically emitted into the atmosphere when these fuels are burned. Sulfur is harmful to people, plants, and oceans. Consequently, governments often require that some sulfur be filtered out before or after combustion. However, even with some filtration, approximately 70 million tons of sulfur dioxide gas are emitted globally into the atmosphere each year. After sulfur dioxide gas is emitted into the atmosphere, it typically combines with water and oxygen to form H2SO4. This nucleates, which means it converts to tiny physical particles. Water sticks to these particles and causes them to grow into physical water droplets. These droplets are so small and sparsely distributed that they are often imperceptible to the naked eye. Droplets containing sulfur typically reflect more sunlight than those without. Therefore, more sulfur causes more sunlight to reflect back into outer space instead of being absorbed by the planet. In effect, sulfur cools the planet. A notable example is the 1991 volcanic eruption of Mount Pinatubo, which released sulfur dioxide gas into the atmosphere, leading to a global temperature decrease of approximately 0.4 degrees Celsius. As mentioned previously, sulfur is present in coal and oil and is released during combustion. In theory, we can filter more of it out before combustion, transport the harvested sulfur to an airplane, and emit it at a high altitude instead of at ground level. High-altitude sulfur stays aloft for 1 to 2 years, while ground-level sulfur typically stays aloft for only several days. Therefore, changing the emission site reduces the planet's temperature without increasing total sulfur emissions. The latter point is important since sulfur is harmful, as noted previously. Sulfur-based materials are not the only substances with reflective properties. For instance, calcium carbonate, commonly known as chalk, exhibits similar capabilities. Further research is needed to understand the benefits and drawbacks of each candidate material. To justify the expense, we would need to compare the cost of cooling the planet with the cost of not cooling the planet. One study suggests large-scale planet cooling would cost approximately $18 billion a year. For comparison, the total value of New York City property is $1,400 billion, and this is just one coastal city that would be lost to sea level rise. If the United States paid half, planet cooling would amount to $27 per American per year. Increasing the reflectivity of the atmosphere is a new field, and there are many things we don't know. We don't know what to inject, when, where, and how. And we don't have an accurate assessment of costs and adverse side effects. To resolve unknowns, we need R&D. This includes developing better instrumentation for measuring atmospheric reflectivity, developing equipment that injects small amounts of material for field experiments, and developing equipment that injects large amounts of material for full-scale operations. And, as noted previously, we have a timing problem. To avoid runaway climate change, our society would need to spend significantly more money on atmospheric reflectivity R&D. In summary, Plan B does exist. However, it is not popular and is therefore mostly being ignored. This is in part due to our denial that Plan A failed due to undersized decarbonisation efforts. In conclusion, it is reasonable to support Plan B with extensive research and development. Thank you for listening.